understood the concept of equilibrium. There are two types of equilibrium. Static equilibrium, when a body is in a state of complete rest, and dynamic equilibrium, when a body is moving with a constant velocity. When all the forces, the net of all forces, that means all the forces that may be acting on a body, balance each other out in such a way that the body is in a state of rest. Alright? So when does a body come in equilibrium? When the net clockwise moment and the net anti-clockwise moment, they become equal. We have learned this in principle of equilibrium. When they become equal, the body comes to a state of rest. So now let us take it a little ahead and try to understand the concept of center of gravity. The center of gravity of a body is unique to itself, and center of gravity of a body is such a point about which all the moments become equal to zero, or collectively all the moments cancel each other out. All the net clockwise moment cancel out all the net anti-clockwise moment. So the body is in a state of equilibrium when it is suspended about its center of gravity. So going by your textbook definition, center of gravity is such a point on a body where the algebraic sum. What does it mean to be an algebraic sum? It means that the clockwise moments are negative and the anti-clockwise moments are taken conventionally as plus. When you add them all with their conventional signs, when you add them all together algebraically, the total sum becomes equal to 0. So can I say center of gravity is such a point where the body comes in a state of equilibrium? And in physics, we always try to eliminate the shape of the body. We always take bodies to be point objects, point charges. So how can we take objects to be point objects if it has some mass and if it has a shape? We can take it as a point object because we consider that all the mass of the body, all the weight of the body acts from the center of gravity. So what are the factors on which center of gravity depends upon? Center of gravity depends upon two major things. One is the distribution of mass. If we have a uniform body in our hand, the body will have equal density wherever we see. So the molecules are at equal separation from each other. In that way, whichever part of the body we see, which we focus on, it will have the same intermolecular separation or the same distance between the two molecules, or we can simply say they will have same uniform distribution of density throughout the body. However, there are some bodies where we don't see this kind of uniformity, which means that the density of the body is different at different places. That will affect the center of mass or center of gravity. Center of gravity hugely also depends on the shape of the body. If I lift one of my legs, I am going to lose my balance. Why? Because the shape of my body has changed. So balancing myself becomes a little difficult. Human body is more or less symmetrical. There is more or less an equal distribution of mass. So when we have similar limbs, hands and legs, they are able to balance us properly. Why do we lose balance? Because the body is no longer in equilibrium, which means that the center of gravity of the body has shifted a little bit. So what are the two factors once again? The distribution of mass and the shape of the body. Now let us look at some examples of a uniform as well as a non-uniform body, and let us try to find their center of gravity. Remember, center of gravity is a unique point to each body, and there is one and only one center of gravity for every body. So I have a square shaped object in my hand. So this is a uniform body because it has uniform shape. Remember, center of gravity depends on the shape of the body, and it is fairly uniformly distributed mass. These kind of uniform bodies, always the center of gravity is at the geometric center. What is the geometric center of a square? We have a square in our hand. The geometric center is a point where the diagonals meet. So if there is a diagonal like this and a diagonal like this, it will meet at the center of the square. So that's where I should be able to balance it. Let us try. So now I have just taken something which appears to be a pivot. So this is my pivot and this is my uniform body. So I am tentatively trying to find out where will my diagonals meet, somewhere over here. So let us try to balance it here. Look, this is the point I am able to balance this body. That means the forces which are on this side and on this side, all the forces which causes anti-clockwise and clockwise moments have balanced each other out. That means the net algebraic sum of the clockwise and anti-clockwise moments is equal to 0. So this is a point of equilibrium. This is also the point of center of gravity of this regular object. Let us look at another example. This is a very common toy. It's a balancing toy or a balancing bird. So again I am back with my pivot. So this is designed in such a manner, this toy is designed in such a manner that if I balance it on its beak, can you see? The body is not toppling over. It is not falling over. Why is that? That's because the anti-clockwise movement and the clockwise movements which are caused on this body have become equal to 0. Their algebraic sum is equal to 0 at this, when the body is balanced at this point. So can I say the beak of this bird is the center of gravity in this case? Right? Alright, can you see how well balanced, how beautifully balanced it is? Because it is designed in such a manner that this beak is the center of gravity for this particular shaped object. If I chop off one of the wings, it will no longer be balanced at this point. It will definitely have another point on which it can be balanced, but this won't remain the point because the shape of the body has changed. Now the question may arise for irregular objects like this. This is an irregularly shaped object. I have just cut any shape on this object. Now where should the center of gravity for this object lie? How do we find that out? To find that out, we just take any point, any 3 points on the object and we try to balance it about that point. That means we try to see where is the body naturally balancing itself when it is suspended about that point. Let us try and see. For example, if I use this point of reference, okay, it's freely moving. Can you see? So now, when I leave it like this, see, it comes to rest at a certain point, right? If I draw a straight line from here, I am drawing a straight line from here downwards towards earth. So I am drawing a line perpendicular to the surface of the earth. So this is my first line, alright? Similarly, I have taken another random point and try to take it at the extreme. You can try this at home. So this is another point. Now here also I have made the body free. Now let's see. It has come to rest. So I am going to draw a straight line. And again I have taken the third point, which is this. And again I am waiting till the body comes to rest. And this is the point that I get. So I am drawing a straight line towards the surface of the earth because a gravitational force of the earth plays a huge role. Now, if you see, these 3 lines will meet at a particular point. These 3 lines will intersect at one point, and that point should be the center of gravity. How to test it? Let's try to balance it at that point. So this is the point of center of gravity. According to our experiment, this is called as the Plum's experiment. So I am going to try to balance it about this point. Which point is this? Where all the 3 straight lines intersect. Alright. So can you see? I have balanced it on the point which was its center of gravity. So you can see how easily I have balanced it at this point. Alright. There is another way to check it. When we can just use our common sense. So if I try to balance it here, what is happening? The body is toppling over on this side. If I try to balance it here, it's toppling over on this side. So if it's toppling here on this side, that means the mass of this side, the mass distribution of this side is more. So I will try to bring my pivot little closer. So whichever side it bends, I will try to take my pivot in that direction so that I can practically get my center of gravity. Here we go. Now it's not bending in any direction. That means the total clockwise and anti-clockwise moments have algebraically become equal to 0. So this is the point of center of gravity of an irregular object.
Children, now we have come to the concept of center of gravity. Center of gravity is something we have been mentioning in our equilibrium, or when we are studying our principle of moments or principle of equilibrium. We are talking about the center point. So let us try to understand what is this center point or center of gravity. Let us take a regular object. Regular object, what does that mean? It means an object which has some line of symmetry. There is a line of symmetry. There is a heart-shaped object, and if I draw a axis of rotation from here, axis of rotation, or can I say if I pivot it along this line AB, what happens? This shape is identical to this shape. So this can also be called as the line of symmetry. Line of symmetry is such a line along which the left hand side and the right hand side are identical. But what if I draw a line over here? Let's call this line CD. So if I draw a line CD, above CD we have this shape, and below CD we have a shape like this. So these two shapes are not identical. So this cannot be your line of symmetry. So we can say that a heart shape is a regular object if and only if the line of symmetry moves something like this. Let us take another regular object, a scale. Let us take a meter scale. We'll have calibrations of 0 centimeter to 100 centimeters. So here you will have calibrations like 10 centimeter mark, 20 centimeter mark, 30, 40, 50, 60, 70, 80, 90 and 100 centimeter. And this is your 0 centimeter. And this is your 100 centimeter. So if this is a uniform meter scale, what did I call it? A uniform. The word is important. Meter scale. Why is it uniform? It is uniform. That means if I take a small part of this scale, the distribution of atoms or molecules of the material that it is made of is uniform. In simple words, we can say that the density of the scale is uniform. It does not have more molecules here and lesser molecules here. Now, for this uniform meter scale, which we have at hand, if I make a line of symmetry like this, because this is passing from the center, this part is 50 centimeter long and this part is also 50 centimeter long. Together they are 100 centimeter long. So this can be a line of symmetry. Can I say this? So if I take the left hand side of the scale and the right hand side of the scale, both will weigh the same. Both will have the same masses. So by saying this, technically what all can we say? We can say that the force exerted by the left hand side of the scale is equal to the force exerted by the right hand side of the scale. That is what it means, because if this mass, this is mkg, this is mkg, correct? So what is the force exerted by left hand side? mkgf. What is the force exerted by the right hand side? mkgf. This is your meter rule. So the marking calibration is 0. Calibration means marking, graduated numbers. So when I call this rod or a scale a uniform scale, when we call a body a uniform scale or a uniform body, that means there is equal density distribution all around the body. That means the number of molecules or atoms which are present on the left hand side, because this is half of the scale, this is 50 centimeter scale. And this is half of the scale, 50 centimeter. Both of them are identical in shape. Both of them are what? They are rectangles. So they are rectangles of equal area, because this height and this height is also same. So this part has same number of molecules as this part. So can I say the weight of the left hand side is equal to the weight of the right hand side? The mass of the left hand side is equal to the mass of the right hand side. So weight of the left hand side is equal to the weight of the right hand side. Let's say this is the pivot. Pivot क्या होता है हमें already पता है. Pivot is a point about which any particular body can rotate. So ML will try to move, because of weight due to L, the body will try to move in the anti-clockwise manner, and because of the right hand side, it will again move towards the pivot. It will try to move with the clockwise manner. From this side, the distance is 50 centimeter. From this side, the distance is 50 centimeter. Mass is also same. Weight is also same. So force due to left hand side is equal to force due to right hand side. Distance of left hand side. So S of left hand side is all distance of the rear end of left hand side is equal to distance of the rear end of the right hand side. So what happens due to principle of moment, clockwise moment here is equal to, clockwise कौन cause कर रहा है, right hand side, is equal to force due to right hand side into distance of right hand side. At anti-clockwise moment is caused by the left hand side. Can you see this? So force due to left hand side into distance of left hand side from the pivot. Correct? But here we know force of right hand side, force of left hand side are same. Distance of left and distance of right are also same. So can I say clockwise moment here is equal to anti-clockwise moment, which means that the body is in equilibrium. What does it mean practically for a body to be in equilibrium? Can I say the scale is at rest? So if I take this point OM, can I say the scale is at rest about the pivot? What is the name of the pivot? OM, the point here at the center. This point at the center. Can you see this point? This point at the center, this point is the balancing point of the scale. Can I say this? Okay. Can I also say the total clockwise moment is equal to the total anti-clockwise moment at this point? I can say this. I have just proven this to you. Now let's say the mass of the scale is 500 grams. Alright. The uniform scale, that means it has equal mass distribution. It has equal density distribution, isn't it? So if the mass is 500 grams, the left hand side, the left half is 250 grams and the right hand side half is also 250 grams. Total mass of the body or the mass of the scale, and where does it act from? First answer is very simple. The total mass of the body is 500 grams. And where will it act from? Now, if I have such a large scale, 1 meter long scale, I want to condense it to a point. So we take into consideration the concept of center of gravity. What is the center of gravity? Center of gravity is such a point in a body. It can be a regular object, it can be an irregular object, it can be a uniform object, it can be a non-uniform object. But center of gravity exists for all bodies of all shapes and sizes. Center of gravity is such a point of a body from which we consider all the masses to act from. Center of gravity is a concept that we have made up. This is our own hypothesis. This makes our calculations easier. Center of gravity will be such a point where all the forces that are acting on a body or all the weights that are acting on a body becomes zero. The fulcrum or the balance can be at any point. So if I have a scale like this, if I balance it at the center at 50 centimeter mark for a 100 centimeter scale, then the mass of the body or the weight of the body is center of gravity, from which we say the weight of the body is acting. So center of gravity is also acting from point O and the pivot is also at point O. So whatever be the mass of the body, what will be the moment that is caused due to the mass? Moment caused due to the mass for a body that is balanced at the center. Balanced at the center मतलब मास जहाँ सेंटर ऑफ ग्रेविटी जहाँ से एक्ट कर रहा है, पॉइंट ओ से एक्ट कर रहा है, बिकॉज वी से सेंटर ऑफ ग्रेविटी इज द पॉइंट वेयर ऑल द मोमेंट्स बिकम इक्वल टू जीरो, उसी पॉइंट पे बैलेंस भी कर रहे हैं. सो व्हाट इज द फोर्स इनटू डिस्प्लेसमेंट, दैट इज द टॉर्क caused by this body or caused on this scale due to the mass of the body, due to the mass of the body, not anything else that is hanging. I am not talking about any other external object. Simply due to the weight of the body itself. What will be the torque that will be experienced? It will be the force, that is 500 GF, correct, into the perpendicular distance of this force from the pivot. What is the perpendicular distance of this force from the pivot? 0. So what will be the moment caused when the body is balanced at its center of gravity? The torque experienced by the body will be equal to 0. But this whole thing changes if I balance this scale, let's say at 60 centimeter mark. 60 centimeter mark पे scale को balance किया है, but center of gravity will always act from the center. So what if you have to find the turning effect experienced by this setup? This is at 50 centimeter mark because center of gravity will always be at the center of the body if it is a uniform body. But pivot can be shifted anywhere. So अभी ये body कहाँ जाएगा? Let us see. Now this is the force which is acting downwards because weight of the body acts from the center. Am I right? So now torque experienced due to the mass of the own scale. The mass of the scale itself will be equal to force experienced by the scale into perpendicular distance from the pivot. Am I right? So what will be the torque experienced in this second case? Torque experienced will be equal to force, that is equal to the mass expressed in GF, that is 500 GF into the distance from the pivot. What is the distance from the pivot? Distance from the pivoted point is going to be 60 minus 50, isn't it? So the torque experience will be 500 GF into 10 centimeters. So the torque experience will be 5000 GF centimeter. This is the torque which is experienced. So the moment the pivot is shifted, now this body will move anti-clockwise towards the pivot always. So this is experienced anti-clockwise. So can you see, without changing the body, if the pivot is shifted, the body will experience some torque. If the pivot is coincident with the center of gravity, if the pivot is coincident with the center of gravity, then due to the weight of the body itself, it will not experience any torque. Torque will be equal to 0. Only and only when pivot and CG are at the same point. So let us look at some important points related to center of gravity. Center of gravity is a fixed point about which the algebraic sum of all moments due to the weight becomes equal to 0. That's exactly what we discussed just now with our meter scale. Okay. Center of gravity will not change. However you place the object, the center of gravity will remain exactly there. It will not change. So the first point that we have to notice, center of gravity of a given mass depends on its shape and not its mass. Matlab center of gravity of a given body, can we say, depends on its shape, but it does not depend on its mass. Let us see what are we trying to say over here. Let's look at this example. Now here there is this one person, same person, who is doing 3 different poses of yoga. So this is the position A where they are standing straight. This is where the center of gravity is. But when they are standing a little tilted, so you can say the leg is raised like this. Now the shape of the body has changed. Mass is the same, it's the same body, but the shape of the body has changed. So here the center of gravity is going to shift a little bit. So here the center of gravity will shift like this. If this is how a person is standing. Okay, these are the feet. So in this case, this part has a majority of the mass of the body. So the center of gravity can possibly shift outside the body And whenever the center of gravity shifts outside the body topples over. What happens? It topples over. Why? Because it has lost balance at this point. Okay, but this is not true for all objects, because some objects can have their natural center of gravity outside their body. When we talk about pregnant women, there is a little bit of protrusion of their tummy. So in that case, the center of gravity can move back and front. Why? Because the shape of the body is changing. So the mass or density does not matter, but the shape of the body is way more relevant for center of gravity. But sometimes when mass of the body increases, the shape also kind of changes. So that will have a passive effect, but not a direct effect. The second point is, the center of gravity is not always within the material of the body. If I take a ring, a circular ring. So this part is hollow. So the center of gravity lies outside the body. Let's take the radius as 7 centimeters. So what will be the length of the ring? Length of the ring will be equal to 2 pi r. That's the circumference, that is 2 into 22 by 7 into 7. That is equal to 44 centimeter will be the length of the ring. Correct? So what I did is, I took this ring and I converted it into a straight line, which is a straight rod. So the length of the rod is going to be 44 centimeter. So tell me, now where will the center of gravity lie? The center of gravity, because we are talking about a uniform object over here, uniform. So the rod is also uniform. I have just taken this ring and I have opened this up. So in this case, the center of gravity is lying well within the ring, at the center of the ring at 22 centimeter from both ends. Yes or no? So the ring is the same thing, made of the same material, but the moment I change the shape of the ring, the center of gravity shifts. It is somewhere else. Alright. Next. So by the concept of center of gravity, the body of net weight, any given weight W, will act from its center of gravity. That means whenever we talk about center of gravity for any shaped object, the center of gravity will always act from such a point where all the moments become equal to 0. So then we stop considering the shape of the body. We only say it is a point object of weight W, which is a collection of all the weights from all the ends of the body, from all the sides of the regular or irregular body. This side has certain weight, this side has certain weight, this part has certain weight, this part has certain weight. So the accumulation of all weights is said to be acting from the CG for practical purposes. Since the center of gravity of a body is a point where all the sum of moments become equal to 0, this we have verified with our scale, it is also called as the balance point of the body. Alright, so understand this concept very clearly. Center of gravity does not depend on the mass, it only depends on the shape of the body. Center of gravity is not always at the center of the body. Center of gravity is a point that we consider for practical purposes, that's where the point, that is the point object from where the entire mass or entire weight of the body is acting from, and center of gravity is a point where all the moments about the point become equal to 0. Therefore, this point is called as the balancing point. Now, very important note for all of you. Very, very important. Balance point is a point where naturally, the moments acting on the body becomes equal to 0. This is not a point where I am balancing the body. If I say there is an object like this, whose balance point is here, that means its center of gravity is here. This is a point if and only if I end up balancing this figure on this point, the body will be stable. If and only if balanced at center of gravity, body will be stable. Okay, but if I want, I can balance it at this point also. But if I try to balance the body at this point, the body will topple. So understand this thing. Balance point is a natural point that if at that point if I balance the body will be stable. But if I want to, I can shift the pivot anywhere I want, but there is no guarantee that the body is going to be stable. The body is going to be stable only and only if CG, that is the center of gravity of that given body, and pivot is a thing that we apply. Pivot is a point or a balance that we apply, like a finger or a pivot scale on the CG, the body is going to be balanced. But if this pivot is not coincident with the CG, that means it is not at the same point as the CG, the body is 100% going to be unbalanced. What is happening over here? This is a uniform bird. So if the center of gravity will lie somewhere along this point. So the center of gravity is actually over here. So if the pivot is set, this is the pivot in this case. If the pivot or an external pivot or an external balancing point is coincident matlab kya? On the same point. If this is your pivot and this is also your CG, can you see how the bird is balanced? But now if I shift the pivot somewhere over here, then the bird will topple. How will it topple? It will topple clockwise. If I place the pivot somewhere over here, the bird will topple. This is the center of gravity. So this is where the weight of the body will act from. अभी यहाँ से weight act कर रहा है, यहाँ पे है pivot. It will move anti-clockwise. Correct? Now, what if I take this same pivot and if I balance it over here, somewhere over here? यहाँ पे balance किया. This does not exist. Now this is where the center of gravity is. This is how the weight will act. Where will it try to go? It will try to go backwards. It will try to go towards the pivot, isn't it? It will always try to go towards the pivot. So how will it move? It will also move. Try to see this in the vertical sense. It will move anti-clockwise. Here it is backwards. But you can see that the motion, if you try to go towards the pivot from point A to the pivot at point B, the motion is actually anti-clockwise. Alright, I think you should be able to verify all this in your own space. Now we are going to see the center of gravity of some common objects. This is a square, so the center of gravity will be at a point where both the diagonals meet. This is a circle, again, two diameters, any two diameters, they meet at this point. For a regular shaped rectangle also, it is at the point of intersection of diagonals. What about a triangle, a scalene triangle? It is a point of intersection where all medians meet. Medians मतलब क्या होता है? Medians is a line which joins the midpoint of a base from the opposite vertex. So if this is the midpoint of this side, the line which joins this midpoint with the opposite vertex is called as the median. How many medians will a triangle have? 3, because there are 3 vertices and 3 sides. So wherever the medians meet is the point about which you can balance the triangle. When you are talking about a circular ring, when you are talking about a disc, the center of gravity lies at its center. When you talk about the ring, this also lies at its center, but the ring is hollow. So basically, the center of gravity of a hollow object always lies outside the object. If this rectangle would have been hollow, this center of gravity where the diagonals meet also would have been outside the object. This is a cylindrical object. Center of gravity lies at height h2 from both bottom and top. This is a solid cone. Remember, solid cone center of gravity lies at a height h by 4. If the whole height is h, if the entire height of the cone is h, so center of gravity lies at h by 4 from the bottom. That means it lies towards the bottom. Why does that happen? That happens because more mass is concentrated here. More weight is exerted in the lower part because it is heavier, it is bulkier. Okay. And if you have to find from the top, it will be 3/4 of h from the top of the cone. The moment it becomes a hollow cone, that means the bulk has decreased. It is less bulky. So that's why the height of the center of gravity moves a little upwards. Now it is h by 3. H by 3 is greater than h by 4. Isn't it? So now the height has gone a little upwards. Why? Why has the center of gravity moved a little upwards? Because when it is a solid cone, a lot of mass is concentrated in the bottom part. But when it becomes a hollow cone, the mass at the bottom is much lesser because it's air or vacuum that fills it. So there is another point that we have to note, that center of gravity shifts towards more mass. क्या मतलब हुआ इसका? If there is an arrangement like this where both are 1 Newton each, so the center of gravity will be at the center. If the distance is 2 meters, the center of gravity will be at a distance of 1 meter from both the sides. Yes. But if this is 1 Newton, this is held by 2 Newton, this distance is 2 meters, the center of gravity will shift towards the bigger weight. So the center of gravity will shift a little towards the right. So center of gravity is not exactly always at the geometrical center. It depends completely on the mass distribution. It depends on the shape of the object. Mass distribution मतलब ही shape of the object. ये shape change हो गया कि नहीं? Here there is more mass. Here there is equal mass.